So, yeah, I think I might have mentioned this one before, and I'm sure anyone who has seen fucking mathematics is familiar with this, right? But, god damn it. Functions are bullshit. So let's have a look at the equation of an ellipse. So here we are given an input, or we get to choose an input variable x and constants a and b. Okay, so I'm just writing xx for x squared and aa for a squared. So yeah, this is y squared over b squared. It's just shorter to write it this way. You might notice that this is fucking the same as the equation of a hyperbola, except for in a hyperbola, one of the terms has a negative on it. Okay? And here with the ellipse, 2a and 2b are not, respectively, the minor and major axes. Right? 2a might be the minor and 2b might be the major, but it could be the other way around. Don't know. Depends which is bigger. But look at this. Look at this shit. Look at that. Same first term. Same first term. The only difference is there's a negative right there. This is the same. This is the same in all three versions. And the hyperbola, one of the terms is negative. It could be the x squared term or the y squared term. Doesn't matter. But, look at this. B on A is the magnitude of the slopes of the asymptotes. Okay? Rise over run, look at that. Rise is y, run is x. Oh my god. And it might be positive or negative. There's one of each. Okay, so now if you understand what these graphs look like, right? What does the graph of an ellipse look like? There's a top half and a bottom half. That's a really weird way to say it, because why would you divide it that way? But function notation, or like the idea of functions, cuts it that way, right? And I find it truly astounding that somebody decided one day that treating these as functions, where half of the graph is lost just due to a philosophical belief, was the correct approach, right? So somebody was like, oh, this is the equation of an ellipse, but actually only the top half is what we're mathematically modeling here. We're not modeling the entire ellipse, because functions. That's fucking retarded. Okay? That just straight up, like, somebody sat down one day and was like, oh, no, this isn't the equation for an ellipse, it's just an equation for the top half. Tell me that's not retarded. Somebody sat down one day and was like, oh, this isn't the equation for a hyperbola, it's just the equation for the top half. What? What the fuck are you talking about? Right? So, like, what should happen for an ellipse as we defined it above? Given an input x, you should get two output values for y when you're actually on the ellipse. When you're away from the ellipse, then you get nothing. You get no outputs. Which is fine. No outputs is not a problem for a function. But more than one input is a problem for a function. Like, that's a stupid thing to be obsessing over. Like, this is our core of mathematics. We're going to just focus on, oh, functions are the most important thing. Fucking why? Why? And it's not that you need an output for every input. It's that if you have outputs for your given inputs, you can only have one of them. Why? Why is that magical? What is so special about that? So, for an ellipse as defined above, given an input x, you should get two output values. For the hyperbola defined above, given an input x, you should get two output values when you're not away from it. Note though, when you're away from the hyperbola, you're in the territory of the ellipse, and when you're away from the ellipse, you're in the territory of the hyperbola. Because it's the same equation. Okay, however, it's actually much worse than this, right? So as I just noted, the ellipse and the two hyperbolae with corresponding a and b values coexist perfectly on the same graph, right? Both of these equations for the hyperbola have the same asymptotes. Right? Right? One One equation gives you a left and right branch of the hyperbola, and the other equation gives you the top and bottom branch. They don't intersect. They don't coincide anywhere. And the ellipse nestles between them, just kissing each of the branches. This is a single graph. If we handled this correctly, there's one equation that handles this entire motherfucking thing. Okay? So yeah, it's much worse than this, because the ellipse and the two hyperbolae with corresponding a and b values coexist perfectly on the same graph. This means for the full graph, any given input of x should yield 4 output values of y, except for like the 2x values where it kisses the left and right, so there you only get 3 values, and the 1x value where the ellipse kisses the top and bottom, and you get only 2 values there. But kind of what actually happened is the ellipse gave you 2 values, and the hyperbola gave you 2 values, and they were the same, so you get just 2 distinct values out of it. Yeah. You could think of it that way. But yeah, this whole thing, like, why? What the fucking Christ? And this absolutely ties into what I've been saying with bivalent logic, because what they want is either a yes or a no. That's what the function is. That's what it's doing. So they're artificially forcing this upon things like this in order to get their clean, oh, it must be true or false. We must, given an input, we either get one value or we get no values. Right? When x is 7, is y something or nothing? And if it's something, it's got to be one thing, because bivalent logic, ooh. And it's important to note, I think, that this concept of how a function works, this reinterpretation of how it works, because originally this, when the idea started really being developed, it wasn't thought that way. So this is a rebranding of functions. This rebranding of functions was part of the precursor to the Hilbert program. Okay. So it is tied into all of this. Bertrand Russell, Alfred Whitehead, Kurt Gödel, all of these people, Alan Turing. It is tied into this very, very intimately. It was basically starting with Gottlob Frege. Yeah, that group right there of that thought that broke a whole bunch of shit, they broke this too. Why are we putting up with this? Like, it's one thing to be the retard that looks at this and like, that's how it should work. It's another to be the retard that gets sucked into that and believes it and looks at, like, for instance, the square root sign, the radical symbol, and is like, oh, that means we only take the principal branch, which is the positive. What? What? What the fuck are you talking about? That's not what it is. That was also a redefinition. That was a redefinition in the same period by these same people, because they believe so strongly in bivalent logic that you either get one answer or no answer. That's it. That's all you get. Right? So when you take the square root of something, what that symbol should mean is you only get one answer. So the square root of 4 isn't positive or negative 2, it's just 2, positive 2. There is some utility in constraining it this way, don't get me wrong, it can be convenient, but completely ignoring the other branch and just denouncing it as that's not what this does, that's dumb. That's dumb, because, so for instance, we're talking about this. When you're taking the square root of something, Okay, when you're taking the square root of something, whether you want just the principal branch or both, or however many there might be more than two. However many there are, that's contextual, right? There is no overarching philosophy you can just pour over this and say, yep, this works always. Unless it's a philosophy that addresses context. Right? Oh, god damn it. Yeah. So this is a consequence of all of this shit that I've been complaining about. Like, this is a real problem, and nobody gives a shit.